Hello, this is Britt Kessel with another example video. In today's video, I'm covering example 3 from section 9-7 in the SavvasRealize Algebra 1 textbook. Today's video covers solving systems of equations using elimination. Alright, so the previous two examples were all about how to solve systems of equations using graphing, which, let's be honest, graphing's a little shady, right? We don't quite like to graph. And so what I'm going to do is I'm going to show you a process called elimination. Remember, to eliminate a variable means to cancel one out. Alright, so to get rid of it. So we're going to line up our equations. We're going to add or subtract the equations in a way that causes one of the variables to delete itself, essentially. Alright, now these are not the steps that Savvas gives. Savvas does it in 2 steps, but these are the must-see steps. So if you're a big person on following a procedure, this might help you out. Alright? Now I do have to zoom in out of that procedure so that I can fit all this writing on the page. But I'll walk you through it as we go. So the first step says to align your variables. So take a look at these equations. Do you see how there's, right here, x squared and the 2x are stacked on each other? Well, those aren't like terms. And so I don't like that they're stacked up like that. I think that's yucky. Same thing with this 4. He should be underneath the 8. Alright? So what I tend to do first, before I even start a problem, is I actually line up the 2 equations to where they are stacked neatly upon one another. Alright? I like the like terms lined up. And so this red equation I'm going to keep as it is. But when I go to write the blue equation underneath it, I'm going to make sure that that 2x and that 4 are underneath their buddies. Alright, I'm not going to put the 2x under the x squared. I'm putting it underneath the 6x so that everything's lined up neatly. Same thing with the minus 4. He belongs with the 8. And so in lining up those variables, I find that it makes it a lot easier when I get to the second step, which is to subtract the functions. Now there's 2 ways in which I could subtract it, alright? One way is just to say minus all that kit and caboodle. But what I tend to find is that people tend to forget that they're subtracting like halfway through the problems. They'll do y minus y and see that that's 0, and they'll be like, oh, I'm good, bye Felicia, and the rest of it they add. And so to help prevent myself from forgetting that I'm subtracting, what I do is I just change the signs on everything that's here in the bottom. So that'll be a negative y, a negative 2x, and this will flip to be a positive 4. And then it's adding down like I'm used to doing, and I don't forget when I have various, signs and variables and stuff messing up in my head. So I could say minus and just put everything in a parenthesis and just remember that I'm subtracting each time. Or you could just flip the signs and add down. And that's what I'm going to do. So y minus y is 0. X squared plus nothing is x squared. Negative 6x minus 2x is a negative 8x. And 8 plus 4 gives me a positive 12. So when I combine that linear equation and the quadratic equation, it has provided me here with a new quadratic function. And so I could solve this quadratic function using whatever method I'm most comfortable using. I could graph it. Ew, nobody has time for that. I could factor it, if it's factorable. I could use completing the square. I could use the quadratic formula. So whatever kind of floats my boat to solve this. Alright, now this is factorable because I could think of 2 numbers that multiply to make 12 that add to make 8. So I'm going to factor it using the double bubble method. But you do you, boo-boo. We probably just got out of a section on the quadratic formula. Might still be in your head. You might sing that beautiful song. Whatever floats your boat. Alright, now with factoring, remember, to get an x squared, you get an x and an x. My first sign is my fall down sign, so that minus comes into my first set of parentheses. And to get a positive 12 with a negative number, I need to multiply it by another negative. So if I'm doing my t-table, I'm figuring out what multiplies to make 12, that adds to make 8. And I could generate the whole list, right? 1 times 12, 2 times 6, 3 times 4, and just find the ones that add to 8. So if you could tell, 2 and 6 is the option for me. So there I've factored it. Now, once you have factored it, you need to actually get the x values. And so to get those x values, you're using what's called the zero product property. So I'm taking each of these pieces of parentheses, and I'm setting it equal to 0. So I say x minus 6 equals 0, and x minus 2 equals 0. And you just solve these little mini equations. So on this side, I add to undo the subtraction, giving me x equals 6. And here I have to add 2 to get rid of the subtraction, and I get x equals 2. So these are the x values to my system of equations. But you have to remember, a system of equations, you're looking for intersection points, right? So you're looking for some kind of ordered pair. And so I have the starts to my ordered pair, but I need the y values so that I could fully describe that location in space. So with any system, once you know your x values, all that you do is you take it back to your original equations to find your y values. And you don't have to plug it into both. You could plug it into just one. So I'm going to plug into the linear one because it's the easier one. But if you do plug it into both, that's a good check to make sure that you're not making any mistakes, because it should work in both the red and the blue. I'm lazy as a human being, so I'm just going to plug into the blue and call it good. So I have y equals 2 times x minus 4. And notice when I put the 6 into the equation, I used parentheses. Here I'm plugging in a 2 using parentheses. Oops. And then you just use your order of operations. So here 2 times 6 is 12. And 12 minus 4 is 8. Here 2 times 2 is 4. And 4 minus 4 is 0. Now be very careful when you bring these y values back that you're matching them with the appropriate x value. So this x value of 6 is what got me the y value of 8. So when I write the 8 up here, it needs to be matched with the 6. And here, when I plugged in the x value of 2, that's what got me the y value of 0. So I want to make sure that that goes into the 0, or into the ordered pair that has the 2. So make sure to kind of match your ordered pairs there. Alright, so the steps look a little bit intimidating, but once you kind of get into it, it's not super bad. Okay? So let's try another one. So my first step was to align my variables, right? Notice I have an x squared underneath an x. That's kind of yucky. Now this part tends to throw off kids because you need to leave a gap in your kind of statement. Right? Like between the x squared and the negative 2, I need to leave a gap to where an x would fall. And between the equal sign and the x, I would need to leave a gap where the x squared would normally go. Now, another thing that's a little bit picky about me is I like to keep my x squared negative because then it makes factoring a lot easier. So when I go to restack my equations, I'm actually going to stack the red one first so that when I go to subtract the two equations from each other, the x squared doesn't flip to being negative. And that's okay. That's not like breaking a rule. Now, if you don't feel comfortable flipping your two equations, like putting the red one on top, when you go and you subtract them, you could always multiply the equation by -1, like whatever equation you get, and that'll flip all the signs in your equation and give you the same thing I'm going to get up here. Alright, so now the next step is going to be to subtract our two equations. Now remember, when I go to subtract, I'm going to flip the signs on this bottom equation here. So instead of having a positive y, I'm going to change it to a negative. Instead of a negative x, I'm going to flip it to a positive x. And instead of a plus 4, I'm going to change it to a minus 4. And that's going to make it to where I could just add down, and I don't have to worry about subtracting negatives, adding negatives, stuff like that. It kind of cleans things. Alright, so y minus y is 0. X squared plus nothing is just x squared. Nothing plus x is just x. And negative 2 minus 4 is negative 6. Now, once again, and kind of a good thing for me, this is factorable. Alright, I could think of numbers that multiply to make 6, that subtract to make, there's a 1 there. Okay? So I'm going to double bubble factor this. If you want to use the quadratic formula, you get that bread. You do you, boo-boo. So to get an x squared, I know that I need an x and an x. My fall down sign is a plus, so I drop my plus down. And then to get a negative 6, I would need a positive times a negative. So I'm going to fill in a negative down there. So then I could create a t-table, or I could just ask myself, what multiplies to make 6 that subtracts to make this 1? Well, that would be 3 and 2. Alright, so then now that I've factored it, now I'm going to use that zero product property, and I'm going to set each of these sets of parentheses equal to 0. So here I'm going to say x plus 3 equals 0, and here I'm going to say x minus 2 equals 0. And that's going to give me my nice little mini equations. That's going to give me those two nice little mini equations so that I can get my x values. So to undo the addition here, I'm subtracting 3 from both sides of the equal sign. And here, to undo the subtraction, I add 2 to each side of the equal sign. So my two x values for my ordered pairs are negative 3 and 2. My next thing, right, is to get my y values. So I could choose whether I want to use the red equation or the green equation. Either one will work. I just find that the linear equation's easier. So I'm going to go with the linear one. So I have y equals negative x, so negative 3 plus 4. And here y equals negative x, so y equals negative 2 plus 4. And we're going to solve these nice little equations. So negative 3 is a positive 3, and 3 plus 4 is 7. I'm going to fill that in because I just replaced that in the negative 3 equation, so I'm going to put that 7 right there. Now here, y equals negative 2, so I could just drop those parentheses. And negative 2 plus 4 is a positive 2. Alright, so let's do it just one more time just to make sure we really get it in our heads with that try it. Alright, now notice they kind of flip things up a little bit. Alright, notice here with the quadratic, there's a negative x squared. And I don't like that, I think that's yucky. So instead of putting this one on top, I'm probably going to put it on the bottom so that that negative x squared turns to a positive x squared. And then here with the linear equation here in the blue, see that it's not in slope-intercept form. That x is before the constant, which is a big no-no. So when we go to write this out, we want to make sure that we're putting it in our standard forms that we need. So like the x squared, the x, then the 2 for the quadratic. And then we need to make sure that we're in slope-intercept form for the next one. All right? So I'm going to put the blue one on top because I don't like the negative x squared that's in the green. And when I'm writing the blue one out, I don't have an x squared term here with this linear function. So I'm leaving a space where the x squared is. And I'm rearranging the x and the 2. Then our green one, I'm just going to write it exactly as I see it because it's already in standard form. And then I'm ready to subtract my two equations. Now when I go to subtract, remember I like to just flip all my signs for my second one. So I'm going to turn that into a negative y, I'm going to turn this into a positive x squared. This will be a minus 4x, and this will be a minus 2. So y minus y is 0. Nothing plus x squared is just x squared. Negative x minus 4x is negative 5x. And 2 minus 2, ooh, that's nothing. So this gives us kind of an interesting equation here. Notice there's no constant value. Now, I personally love when there's no constant value, because then I could just factor out the greatest common factor. Could I still use the quadratic formula? You betcha. I could put a plus 0 here, and I could just kind of figure it out that way with a c value of 0. But nay, that is way too much work. Here, instead, I'm just going to factor an x out of the expression. So x squared divided by x is just x. Negative 5x divided by x is just negative 5. And so by pulling that x out, now I have two expressions that are that are multiplied to each other, and I could just set them equal to 0 and get easy answers out of them with our zero product property. So that first one I say x equals 0, and here I say x minus 5 equals 0. This first one, the x value is solved for us. You just get a 0. And then on the second mini equation, to undo the subtracting of 5, I'm adding 5 to each side. That's why I get x equals 5. And then our last step, of course, now that we know what x is, now we're going to solve for y. So I'm going to bring these x's back to one of my two equations. Now that green equation looks real beefy. I'm not going to worry about it. Instead, I'm going to deal with that blue one. So I'm going to say y equals 2 minus 0, and y equals 2 minus 5. Oops, putting my parentheses in the wrong spot. And we're just going to simplify those two mini equations. So here 2 minus 0 is 2, and here 2 minus 5 is negative 3. And so we just fill those into our ordered pairs. And there we have it, y'all. That is how to solve systems of equations using elimination. Until next time.